Welcome to the chip market, where we help you invest smarter in the world of chips. Now, we already know that quantum computers are coming, and they pose a huge threat to our digital world. So today, we're diving into the solution, the post-quantum cryptography imperative.
Here's what we're going to cover. First, we'll look at the new cryptographic standards, the quantum safe answer itself. Then, we'll walk through the practical playbook for how big companies can actually make this switch. After that, we'll get into the investment landscape this whole transition is kicking off. And finally, we'll talk about why the future of security is really all about being crypto-agile.
All right, let's get right into it. The encryption that protects everything today, think RSA and ECC, is on a collision course with quantum computers. So the urgent question isn't if we need to replace it anymore. The question is, what does that replacement actually look like?
Well, the good news is the global security community has been on this for years. Their answer is a whole new generation of algorithms, and we call it post-quantum cryptography, or PQC for short.
And listen, this isn't some far-off theoretical thing. It is happening right now. Just look at this timeline. In 2024, the U.S. National Institute of Standards and Technology, that's NIST, officially finalized the first set of PQC standards. The clock is ticking. By 2030, the recommendation is to stop using the old vulnerable stuff, and by 2035, that's the hard deadline for the full migration. The urgency is crystal clear, and the roadmap for the next decade is set.
So, what's actually in this new cryptographic toolkit? Well, after a long, multi-year competition, NIST picked three main algorithms. You've got Crystal's Kyber, which is for establishing a secure connection in the first place. Then there's Crystal's Dilithium, and that's the new go-to for digital signatures, proving you are who you say you are. And then there's Sphinx Plus. Now this one is really interesting. It's a fallback, a backup. And its real value is that it's built on totally different math. See, the first two are lattice-based. Sphinx Plus is hash-based. What does that matter? It gives us crucial diversity. It's a hedge, just in case a flaw is ever discovered in the lattice-based approach. Super smart.
Okay, so we've got these new standards. That's great. But how does a massive company actually start using them? The conversation is shifting now from theory to practice, and thankfully, there's a clear roadmap for organizations to follow. And just to give you a sense of the scale here, take a look at this quote from Moody's. They're comparing the PQC migration to the Y2K problem. For those who remember, that was a gigantic, expensive, system-wide overhaul. Y2K cost over $100 billion in the US alone. So let's be clear, this isn't just installing a patch. This is a fundamental upgrade to the entire digital economy.
The key thing to know is that you can manage this huge task with a structured, four-step approach. It all starts with a full inventory. I mean, you can't protect what you don't know you have, right? From there, you prioritize, focusing on your most sensitive, long-lasting data first. Then comes the really critical part, testing and prototyping to make sure the new stuff works without breaking everything else. And finally, you do a phased rollout, maybe even running old and new systems side by side for a while before you finally pull the plug on the old, vulnerable crypto.
Now, there's a core principle that makes this whole playbook work, and it's called crypto agility. Basically, it means designing systems that aren't locked into one specific algorithm. It's all about building an architecture that can adapt. So if a new standard comes along, or, and this is a big one, if a vulnerability is discovered, a crypto-agile system can be updated with a simple switch, not a painful multi-year redesign. It's the absolute key to future-proofing your security. You know, whenever you have a transition of this magnitude, it naturally creates a huge economic shift. And for investors, that means a brand new, fast-growing market is taking shape. It's got its big players, its innovative startups, and of course, its own unique set of risks.
And the numbers here, well, they really do speak for themselves. The PQC market is projected to just explode, from about $1 billion in 2025 to over $21 billion by 2034. That's a compound annual growth rate of nearly 40%. That kind of growth is driven by hard deadlines and the sheer strategic need to keep data safe.
So who's in this market? It's a really diverse ecosystem. You've got the tech giants like IBM, Google, and Microsoft, who are, funny enough, building both the quantum computers and the defenses against them. Then you have the hardware and security vendors like Thales and Intel. They're the ones making the chips and modules that'll actually run all these new algorithms. And you've got this exciting field of specialized startups like PQShield, which is focused on hardware, and SandboxAQ, which spun out of Google to help companies with the migration itself.
This right here perfectly illustrates the biggest risk for investors in this space. If you bet on a company whose entire value is tied to one single algorithm, that is incredibly risky.
And we saw a perfect example of this in 2022. There was a promising algorithm called Cyc that, out of nowhere, was broken by regular computers. A company built entirely on Cyc would have been wiped out overnight. The smarter bet? It's the companies that offer crypto-agile platforms, flexible solutions that can handle any standard. They're just far more resilient.
And that brings us to our final point. Getting through this initial migration to PQC, well, that's not the end of the story. It's really the beginning of a new, much more dynamic way of thinking about security.
It's so important to get this. PQC fixes the problem of quantum computers breaking our current encryption, but it is not a silver bullet for all of cybersecurity. Once PQC is in place, attackers will just shift their focus to other weak spots. Bad code, tricking employees, you name it. PQC becomes the new foundation, the new baseline, but it has to be part of a much bigger defense strategy.
And beyond the PQC algorithms, other technologies are going to add more layers of security. There's something called quantum key distribution, or QKD, which uses physics itself to secure communication lines. You'll see next-gen hardware designed specifically to protect these new, larger PQC keys. But most importantly, that idea of crypto agility, that's not a one-time project. It becomes an ongoing strategy, a permanent state of readiness for whatever threat comes next.
Let's close out with a thought experiment. Imagine there's a huge breakthrough, and a powerful quantum computer arrives in, say, 2030, way ahead of schedule. That would trigger what some are calling a Y2Q, or year to quantum moment. It would be a security earthquake. For any company that put this off, it would be pure chaos. But for the ones who followed the roadmap and did the work ahead of time, it would be a non-event. This scenario is exactly why waiting is just not a strategy.
So in the end, this whole shift post-quantum cryptography isn't just about checking a compliance box. It is a strategic necessity to protect our entire digital world. And for those paying attention, it's one of the most defining investment opportunities in technology for the next decade. Thanks so much for watching. To stay informed in this space, please share this explainer and make sure you subscribe to the Chip Market for more insights.